Dear doctors and professor, good afternoon. My name is Mohammed Ali and I'm the host. And I'm going to be doing today's project 2 presentation, which was about the advanced smart stick, the advanced smart stick for the visually impaired, with my colleagues Mohammed Adham, Dia and Abdurrahman. So with project 2, we have carried on and resumed with upgrading and adjusting the things that we had for project 1. And the same committee, if you remember, doctors, we did the smart advanced stick for the visually impaired. However, this time with much adjustment and much features that are effective, and we are going to show. So this is the final prototype. Not much has changed compared to project 2. However, right now we are going to see the main features that we did for this project in a short video.
And welcome to the updated version of the Advanced Smart Stick for the visually impaired. We will take a quick flashback to what we did in Project 1 to show the adjustments and updates Project 2 has received. In Project 1, we had 2 ultrasonic sensors that their objective was obstacle detection, as well as having a shock sensor that triggers once the stick falls on the ground, allowing the stick user to identify the stick's location easily. To avoid the continuous buzzer sound when being in a crowded environment, a killer switch was added. Finally, we had a big feature, which was the RFID scanner, where it scans program tags and leads the user to the correct placement. Now, it's time for Project 2 to shine. Our main goal for this project is to push ourselves to the extreme, brainstorming and finding creative ideas and ways to design the ultimate stick for the visually impaired. A stick that does everything a sighted person is capable of doing, allowing the visually impaired to be fully self-independent. The following act is going to be played by my colleague Abdurrahman, where he will resemble a visually impaired person. Starting off with the first feature, again, is the RFID sensor. Abdurrahman is a student who feels embarrassed all the time, seeking for someone's assistance, as he is a visually impaired student. Well, when using the advanced smart stick for the visually impaired, that wouldn't be a problem, dear Abdurrahman. With the RFID scanner, that content would be displayed on the software application using text and speech. Abdurrahman will now join the lecture safely. It's the end of the lecture, and Abdurrahman is now leaving and also feeling thirsty, hoping he can get the correct banknote to process the payment. For that, an artificial intelligence camera lens under the name of Husky lens was used to identify the info object in front of the camera. The banknotes were programmed and also stored and can be displayed on the software. For this case, Abdurrahman needs 5 dirhams. The artificial intelligence will immediately inform Abdurrahman that he is passing 10 dirhams instead of 5, as we can see from the video. Abdurrahman now recognizes that he showed 10 and not 5 dirhams. Abdurrahman now walks away, and as you can see, a small liquid is on the ground with a caution sign. To inform Abdurrahman, a water sensor has been used to indicate a spoiled liquid, resulting in triggering sound buzzer. Next, we have the facial recognition, also performed by the Husky lens. Once a person interrupts Abdurrahman and stands in front of him and says hi, Abdurrahman can direct the lens to the person's face, and the name will be displayed on the software by text and speech features, and that's only if the person's face is stored in the database of the camera. Finally, we have the ground hole detection ultrasonic sensor. After testing the stick and the Emirates Association of the Visually Impaired, we noticed a visually impaired person using a manual stick coming down the stairs. So we got the idea of adding a third ultrasonic sensor that detects ground holes and also low grounds. Thank you so much, doctors and professors, for your listening, and we are ready for any questions.
So basically, I'm going to summarize the abstract that we discussed in Project 1 and Project 2. Project 1 is this left part. So the main goal was detecting high and low obstacles, while in Project 2 we thought of another ideas and covering all dangerous scenarios that could be possible for the visual impaired person, which is detecting water or spoiled liquid, and also detecting holes and low ground. In this case, we have covered every dangerous scenario a visual impaired can be experiencing. Right now, I'm going to give the mic to my colleague Abdurrahman, who will explain the hardware level component of the project.
Thank you, my colleague Mohammed. Good afternoon, doctors and professors. As you know, we made our project last semester, but now we want to improve our project more and more. So we added some components. Let us discuss our components, Mohammed. Previously, we used 2 ultrasonic sensors to detect the upcoming objects. And now we add 1 more to detect the ground holes. Previously, we discussed and we explained everything about ultrasonic, but now I will discuss how we connect the ultrasonic to our pin or to our plane, which is Arduino. We connect the VCC to the voltage, ground to the ground. The trigger or the transmitter, we connect it to the pin number 4, and the echo, which is the receiver, we connect it to pin number 5 in the Arduino. Next. Moisture or soil moisture sensor, which is basically a water sensor. It's mostly used by farmers in their big lands to check the water in each plant. This sensor comes with a potentiometer to control or adjust the sensitivity on each plant, on each spot of water. When the blind person or when the stick touches a spot of water or liquid spoil, the buzzer will trigger and will make a high sound, so the person can take it. Next, please. We want a sensor to check the water, the spot of water or liquid spoil. So no need to insert the stick under the ground or the sensor specifically. So we remove the head and we replace it with these red wires, so the person can't break it by mistake or scratch it. As you can see, 4 pins, VCC, ground, A0 and D0. A0, as we can see clearly from this table, we neglect it. Why? Because the analog pin helps us to know what is the percentage of the water. And in our case, we don't want it. We just want to know if there is water or not, 1 or 0. That's why we connect the DO, which is digital pin, to pin number 6. And this is the potentiometer, the blue box, as I discussed. Husky Lens. Husky Lens is artificial intelligence machine. It is equipped with many features like object tracking, face recognition, object recognition, etc. In our project, we mainly use just 2 features, face recognition and currency reading. The connection of the Husky Lens, we connect plus and minus, as we know. The transmitter and the TX and the RX, we connect TX to the SDA and RX to the SCL. Why only these 2 pins? Because the Husky Lens deals with hexadecimal format, not binary format. So in the Arduino, the SDA and SCL deals with the binary format. That's why we connect them to these specific pins. Next time. The procedure of the Husky Lens is quite simple. It's just the person can scroll or choose, select the operation with the face recognition or currency reading using his application that we made it in the smartphones. My colleague Bea will explain it well. And after the person select the operation, he directs the camera towards the faces or the currency he wants, and the application will tell him the result, who is the person or how much the amount. How it works, my colleague Mohammed Adham now will discuss it while he is analyzing the code. Mohammed, take it.
Thank you to my colleague Abdurrahman. Good afternoon, everybody. As you know, we have added quite a few new components to our project. So obviously, we're going to be coding a lot of the new components in our new project. And we started off with the Husky Lens library. It's very essential to us because Husky Lens has a lot of functions that we want to use, a lot of functions that we want to use. So we're just going to call the library here. And after that, we have the software serial library, which basically helps us communicate between the cell phone and the Arduino by Bluetooth. And then we also here declared the Husky Lens, which is going to be used throughout the entire code. And for this print result as well, We're going to use it later on in our code. And then we have the integer cam ID, which basically means every time we pan the camera over to a face or any banknote, it's going to give us, it's going to generate a random and unique ID number. And that ID number is going to be assigned to whatever we scan the camera to. And then you also have the integer mode equals 0. In our Husky Lens, we have a lot of modes. We have mode number 1, which is for currency reading, and then number 2, which is for face recognition. And mode 0 just tells us that we're at the starting position of the camera. We also define the water sensor here. We connected it to pin number 6, and we also declared a variable here for water state, just to tell us when to trigger. 0 doesn't work, and then 1 if there's water. And then for this block of code right here, we just we called all of the ultrasonic sensors. The first 2 we declared in our previous project, and then the third one is the new one that we added. It was connected to pin number 4 and 5, and it's the one that detects any holes or any lower ground distances. For these 2 functions right here, basically we got it from the Husky Lens library, and it just indicates or tells the Arduino to start working and to begin all of its functions. And for this block as well, again, we are just declaring all of the ultrasonic sensors right here, and it's going to read and detect everything that's in front of it. And for the water sensor right here, if it detects any type of water, it's going to work at low state. Now you might be wondering, why does it work at low state? Because the water sensor is an inverter function, which means that it operates at low and it doesn't work at high. And we also added a delay of 1 second over here just to avoid any type of errors. And for this serial print, it just helps us detect all of the outcomes on the monitor. For this block of code right here, basically it just explains if there is any Bluetooth connection available, then it is going to send some type of characters to our software using the Arduino as well, which basically means that like between our camera and the software, it sends characters. That's how it communicates. So for character F, we put it for face recognition, and then for character L, we put it on object classification, which is going to be using as currency recognition. If we detect the camera on someone's face, it's going to be on mode 2, and it's going to send the character F. And then if we pan it over to any banknote or whatever, it's going to send the letter L, and it's going to be on mode 1. And for this block of code as well, it's pretty simple. If the Husky Lens requests any type of, or detects any type of whatever is in front of it, then it's going to go into the while loop right here, and it is going to read whatever is in front of it, and it's going to print result, which is, next slide please. It's going to print it right here, which we discussed in the first slide, which is the print result. This helps us in printing the ID number that we got from when we directed the camera at the object, and then it's going to store it into our camera, and then we are going to assign each and every ID number that we got to the node, in this example, to the node that we use the camera on. For example, we moved the camera into our 5 dirham node, and we got the cam ID number 2. So we just assigned these 2 together, and we added the cam ID equals 0 to avoid any continuous looping in the code with a delay of 3 seconds. And as you can see, the camera ID 3 and 4 is for 110 dirham as well. Same here, it's working on the facial recognition mode, which is mode number 2. And when we pan over the camera to Muhammad Ali's face, we got the ID number 1. So we just connected these 2, like we assigned the name Muhammad Ali to the ID number 1. And again, we used the cam ID equals 0 just to avoid any continuous looping with the code with a delay of 3 seconds. And as you can see, number 2 to my face, 3 and 4 to Abdurrahman and Diaz. And for this last block of code, it's pretty simple. It's just, it calculates distance for every ultrasonic sensor. For these 2 right here, it is for the previous project, if it's less than 50. For this one, it's going to be for the new ultrasonic sensor. If it's bigger than 30, if the distance between us and the ground is bigger than 30, there's going to be vibration is going to be triggering into the stick. And here, if there's nothing dangerous, then it's not going to be working. There's no vibration. And you might be wondering, where is the buzzer sound? Well, we transferred the buzzer sound from this to the water sensor just to distinguish which is which. And that's it from my part. Now I'm going to give the floor to my colleague, Dia.
Good afternoon. Hello, my name is Dia. Now I will talk about the application. our goal was simple. We want to create the best experience ever to help the blind people. Blind stick application, we have bring three things. The first one, face recognition. Face recognition is blind assistant to identify people and to know his friend easily. The second one is currency reading. It's helping to find out the amount with him and to prevent fraud. The third one is NFC reading or NFC tag. So in the stick we have NFC. We need this application to convert the reading of NFC to speech. Now let's take a look at the program. This is our program. This is our application designed from outside, and this our program for project 1. We faced a lot of problem. We take it from App Store. It was ready, and we make an application because we faced a lot of problem. The first problem it was not working in background when you want to close the screen mobile. It will not work, and when we add the camera, so in the ready application it will not work the camera. Let's start with university motto, and when we click in the motto, it will move to another screen. And as we can see, if it's disconnected, it will show you it's disconnected. And we have two options, as we can see, face recognition and currency reading. And when it's connected, it will show you if it's connected. So when we click in any option of this, so the camera will work in this stick, and we can select any option. If we want to currency reading, so he just have to scan the money, and he will convert from reading to speech. So that was the blind stick application. Back to my
colleague there. As a conclusion, we would like to say it was an honor for us to adopt this project, and we have achieved our objectives was to create a light, small, especially mobile stick. However, our plans does not stop here. Just because this is the end of the project 2, that does not mean that it is the end of our future plans. Because we have, as a future plan, to make this as small as possible, especially getting the of the voice, as you can see. This is causing some problems, especially putting in the eye. So we are planning later on, inshallah, to have it in nanotechnology, which is basically making things smaller. And this is the technology that they use for everything, smartphones, everything. Everything starts with huge, and starts with this room, and going to be as small as this pin. However, this is a costly and expensive operation, and it's not done everywhere, not in every country. But we're hoping and seeking your service, doctors, and the university, hoping to get this into the production later on. Thank you so much, doctors and professors, and we are ready for any questions.
So my understanding that you added the water sensor and also the pulse, sensor, and also you detect the images, right? So these are three things you have.
Yes, we have the water sensor, we have the new ultrasonic for the ground detection, and we have the
Haskell.
The Husky.
That's what I said, three things.
Yes.
and the application.
Yeah, my question now, what is the database of the restored images?
Yeah, so basically I will show the camera.
No, not here, no, just speak about it.
Yes, the camera is inside. First of all, the purpose of this camera is that it shows the images of a single shot. For example, if I wanted to store the faces of every student, I have to do it in a one loop. And this is the downside of this camera. Although it's an expensive camera, however, it does not contain like that database that every time you can store one after another. So if in case you want to store, for example, a face, you have to store everything by once.
My question that this is restored images, isn't it?
You mean like when taking pictures?
What's face recognition?
Yes, please store. It's stored inside.
We can capture the image, and it will save the camera, and we
It
program
is
it.
saved inside. For
The
example,
camera will give us the random number.
ID, and then we can put the name to the ID and program.
the names are
I think you mentioned that you can store some friends' images in there.
yes.
Yes.
It's inside the camera.
It's inside the camera.
Yes,
Inside the
the camera is
Not
already
in the
there.
software.
Yeah, but then for space, it's not too much to say, I think, for such.
Yeah, but this is just a prototype, doctor.
What is the size of the camera memory? Can you tell us? What is the size?
The camera is not that much. I think it's in kilobytes. I'm not sure the exact.
How many images can you store in a few kilobytes?
You can sell as much as many. Like you can sell up to 100. I'm not sure the exact size. However, the downside, doctor, is that every time like you try to scan or store another face after the power off has been done, power it on, everything previously will be deleted. This is the downside. And also the downside is that you cannot control the camera from the phone. Like you have to take the camera outside and take a picture and return it inside. So this is the negative part that we were disappointed about.
So what do you think that if you're going to upgrade it, what's the way how you're going to improve such things?
Actually, doctor, we have searched for much smarter and much better cameras. However, we did not find a camera that can be communicated directly with the.
For the current situation, we have any other solutions?
At the moment, right now, no.
Because this version of this camera, this is the way we can store.
Maybe
for
you
it.
don't have to store in the camera to some other.
You mean mobile phone, for example, take picture? Yeah, we searched for this point and we couldn't.
Maybe server. Maybe there's a connection to server and you can store things.
We actually thought about having like an extra thing as a memory, but the problem is that the size. Everything that we saw, it has a size, either a length or weight, which will cause some problems. Yeah, but if you like carry it on, doctor, it won't be. It will be like you can carry it on.
No. Because for example, what if it's a server? What do you need server? Maybe you need some communication link between here and there, like within your maybe a communication link and you can store what you like in server. Yeah, come on. Yes.
Yeah, it could be for the
Sure,
mobile.
yeah.
Yes.
Oh, so another thing that goes for the water sensor. When you have a sensor, must be, for example, the water must be too much that can. I mean, the sensor can detect it, right? But suppose if it's slippery, it's flowing.
Actually, Professor, as you can see, it was not clear, but those are the wires. So the cane will be held this way. So any part of it, but it's not there's a spot of water. Any slippery like liquid.
Liquid
yeah,
spoil.
because this is too much sensitive.
No, because when it's slippery, the contact cannot be made, right? Because it has to be made contact between two things, isn't it?
It has to be contact with the.
Yeah, so this means suppose it's slippery without contact.
You mean
This is usually find a sign there and please be careful.
Yeah, I got it. Yeah.
People don't
well,
read the sign, right?
Yeah, we certainly believe that controlling the potential meter as my colleague
Is there any way that there's a problem? Is there any way that you can solve such a problem?
No, I'm not sure. But this is too much, too sensitive. Like we can.
Yeah, we can
adjust the
We
potential
can think
meter.
about something else.
We can program the Haskellans for the signs of waters. So it will detect.
From the potential meter, you can adjust the sensitivity to be as much as possible. So any like non dry surface, it will detect it immediately.
This is the director.
Okay, well, it's admirable you've done spherical and a very ambitious project, part of the software skills and all that you implemented in the code, but I had some doubts about the practicality. Of course, we can argue this is the prototype and it's going to be micro-engineered or in an integrated form. A few questions on the functionality. Okay, you have a water sensor together with a hole detection. How can you pair the two together?
I'm sorry.
There is a hole detection, hole in the ground.
Yes.
Yeah. So this is also incorporated in the tip of the stick, isn't it?
Yeah, they are not related. However, they are close to each other. I'll just show you.
Yeah, close.
Yes. So basically, Professor, this is the ultrasonic sensor.
Okay, and this detects the holes in the ground.
Sorry.
This
Yes,
is for
it
detecting
does,
the
it
holes.
does,
Yes,
it does this. So
yes.
I'm just saying that on. So as you can
Okay.
see, right now there's no vibration. So once I
Okay.
try to lift it up, vibration. This will
Okay.
indicate that there is a low ground, especially going to stay at the ground.
Okay, another question. What about if it's oil? Will you be able to detect the oil in
Oil.
the ground? Yes, okay. This is more dangerous than water.
Yeah,
Yes,
yes.
water can be detected.
Yeah.
Any liquid you can
By the water.
As much as it's so close to the.
Because I've seen these things that usually they put in the garden, they put them in the ground so they detect the moisture when the sprinklers will come on. And,
Yes, this is actually,
But,
yeah, this is not actually, this is not a water sensor originally. This is a soil and moisture. This is
Okay.
usually done, as you can
So
see.
any
Can
liquid
you,
soil.
can you check the response time of this? You know, if its response time is a few minutes, this water sensor, liquid sensor.
Immediately, it does
It is immediate.
immediately with the sun buzzer.
Okay.
Can detect now even the depth of the water is not too much. Practically, can
Yes.
Yes, even if it's deep or shallow, it detects both.
Any liquid spoil.
I mean the depth of the water.
The depth?
No,
No.
I think
Because
it
the
doesn't
use
say
just this is not we have
Yeah, this is what I mean, practicality, maybe there is some other means, right?
Yeah.
To do, right?
Yes,
Because
yes.
this is the road. For example, let's say by regulation, maybe you have the sign, the warning sign must have a transmitter somewhere and you can detect it, right? Because maybe you cannot read, you can read, right? There is some other ways to add it to your.
Yes.
because the main idea is that we don't want we just want to visually impaired to use this just to indicate if there is slippery or a liquid spoil in the ground. We don't want to measure the depth of the water.
Another thing is, I do not understand what is the functionality of having a Bluetooth connection unless it's an audio.
For camera.
Audio view.
Bluetooth connection, Professor.
I've seen you working with a mobile in one
Yes.
hand and sticking the other. So is this the final scenario?
No, because
It's just to convert the reading of NFC to speech, and without that you cannot see it.
Is there a buzzer as well?
Yes,
Yes.
sound buzzer. Sound buzzer.
Okay.
This is the killer switch, as mentioned. We can just.
But why should there be, why should there be a connection via communication link via Bluetooth? Why can't this all take